Very well. Let's move on to more sets. Let's take a look at the following examples. Now I'm going to give you some sets and I'm going to ask you to identify the members of these sets. Example. Identify the members of each set. Very good. Okay. The very first set, set A, is given to you as the set of all values such that X is positive and X belongs to R. Okay, let's just break these down. What are they talking about? What are these? So first of all, let's learn how to read this. The set of X all values such that with the property that those are positive numbers and at the same time they belong to R. They are real numbers. Remember that. Let's just go over a very short recall. Remember that we introduced natural numbers as counting numbers in algebra. N, bolded N, is called the natural numbers. Starting from 1, then 2, then 3, then 4, and the rest of the counting numbers. This is N, natural numbers. After natural numbers, we define the whole numbers using W. This set doesn't have any zero. So we're going to add 0 to it and call it a new set, whole numbers. So this guy is 0, then 1, then 2, then 3, then 4, and the rest of the numbers. Well, these, they don't have any negative numbers, am I right? So we're going to add negative numbers to this set and create something new. Z or I representing the integers. Okay. This set has some negative numbers. -3, -2, -1, 0, 1, 2, 3, and the rest of the positive numbers. Well, we might say, hey, we don't see any fractions here. We're going to define fractions as rational numbers. Rational numbers or fractions, which represented by the set A over B, such that B is never 0 and B is an integer. Okay. Let me just move this a little bit. B is also an integer, A and B are integers. You might say, hey, I don't see any radical 2, square root of 2, square root of 3. I don't see pi here. I don't see Napier number here. What about those poor numbers? Those are called irrational numbers. Irrational numbers, or the complement of rationals. Irrational numbers. Square root of 2, negative square root of 5, pi, and the rest of the numbers that are not in the form of A divided by B, such that the numerator and the denominator are integers, they are called irrational numbers. R, or real line, is Q union with QC, or irrationals. This guy is called real numbers or just real set. Very good. Well, just a quick reminder about the algebra when we see R. What's the meaning of R? R can take on any values, right? Any number. When you were in algebra and you had real lines, the real line from negative infinity to positive infinity, this real line included all numbers on the horizontal line, and we call this the real number set or just a real line, x-axis or y-axis. In this example, it says, hey, you have a set. That set includes all numbers. What numbers? All numbers that are positive and at the same time, they are real values. Okay. This guy describes, this is the set. This is the set of all positive and real numbers. How do I visualize that? Well, okay, it's not that hard. It's not that difficult. I have my x-axis, negative infinity to positive infinity. 0 is here. 0 is not included. So you're going to put an open dot, an open circle here and shade the right-hand side. Or as you remember, this is open interval 0 to positive infinity. This guy represents this set. Open interval 0 to positive infinity. All numbers that are positive and they are real values.